For those of you who don't know, I am a huge believer in the fact that we as humans do not perceive our current state of reality to actually be reality. For example, to be born into a world where we only know what we currently perceive is in fact a misnomer, or a wrong or inaccurate environment that we ourselves have created. In the book that I am writing, I quote a Bible scripture of Genesis chapter 1 verse 1. And as most of us are aware, that scripture states, "In the beginning God created the heavens and the earth." This scripture is not literally talking about anything physical. It is purely a metaphor. In the beginning means God consciousness or alpha. God, meaning you, created the heavens and the earth, means our separation from God, or our true identity. Basically it means that we separated from a God-conscious state developed by choice. And that choice was conceived by the ego. So essentially a separation from oneness that resulted in duality. Another metaphor that correlates to this illustration is that of the prodigal son. That whole example is based upon consciousness as we perceive it to create choice. Now, remember that the term choice is a dualistic term. Thus the separation unfolds all what we perceive as reality. The reality that we are experiencing is no more advanced in its environment than a goldfish in its own bowl. We are that goldfish. The universe doesn't exist if we stop looking at it. This is according to a famous theory in quantum mechanics which argues that a particle's past behavior changes based on what we see. Now, scientists have performed a new experiment proving this theory to be true on the scale of atoms. So let's look at this from a scientific standpoint. According to the rules of quantum mechanics, the boundary between the world out there and our own subjective consciousness are blurred. When physicists look at atoms or particles of light, what they see depends on how they have set up their experiment. To test this, physicists at the Australian National University recently conducted what is known as the John Wheeler's Delayed Choice Thought Experiment. The experiment involves a moving object that is given the choice to act like a particle or a wave. Wheeler's experiment then asks, at which point does the object decide? Common sense says the object is either wave-like or particle-like, independent of how we measure it. But quantum physics predicts that whether you observe wave-like behavior or particle behavior depends only on how it is actually measured at the end of its journey. This is exactly what the Australian team found. It proves that measurement is everything. At the quantum level, reality does not exist if you are not looking at it, said Associate Professor Andrew Truscott. Despite the apparent weirdness, the results confirm the validity of quantum theory. Quantum theory governs the world of the very small, and has enabled the development of many technologies such as LEDs, lasers and computer chips. The ANA reversed Wheeler's original concept of light beams being bounced by mirrors, and instead used atoms scattered by laser light. Quantum physics predictions about interference seem odd enough when applied to light, which seems more like a wave, said PhD student Roman Kakimov. But to have done the experiment with atoms, which are complicated things that have mass and interact with electric fields and so on, adds to the weirdness. Professor Truscott's team first trapped a collection of helium atoms in a suspended state known as a Bose-Einstein condensate, and then ejected them until there was only a single atom left. The single atom was then dropped through a pair of laser beams, which formed a grating pattern that acted as crossroads in the same way a solid grating would scatter light. A second light grating to recombine the paths was randomly added, which led to constructive or destructive interference as if the atom had traveled both paths. When the second light grating was not added, no interference was seen as if the atom chose only one path. However, the random number determining whether the grating was added was only generated after the atom had passed through the crossroads. If you choose to believe that the atom really did take a particular path or paths, then you have to accept that a future measurement is affecting the atom's past, said Truscott. The atoms did not travel from A to B. It was only when they were measured at the end of the journey that their wave-like or particle-like behavior was brought into existence, he said.